Hello class, welcome back. Today we're going to get started on section 5.3, right? The binomial distribution, right? And by now we should have already been done, right? Skimming, reading the section, right? Reading section 5.3, right? And let's go ahead and get started, right? So the binomial distribution formula we're going to be using in this section, right, is here. In a binomial experiment, the probability of exactly X successes in N trials is given by that formula right here, right? P of X is equal to N factorial over N minus X factorial times X factorial times P raised to the X times Q raised to the N minus X. It's quite a lot, right? Quite a lot. So let's go ahead and dissect all of that, right? So specifically here, I'm talking about X successes, right? So if you want to go ahead and follow along, this is going to be in page 284 of your book, right, on the lower left, right? This here, right there, that's going to be the symbol, right, for the probability of success, right? It can be success or failure based on what you're given, all right? And here, right, we're specifically talking about success. All right, so that right there is going to be the probability of success, right? If we look at P right there, right, that's going to be the numerical probability of success, right? If you look at Q, right, Q there, it's going to be the numerical probability of a failure. And how do you find Q, right? Q is equivalent to 1 minus P. All right, because if we were to go ahead and move this P over, all right, we know that the probability of success plus the probability of failure should equal 1, all right? Should equal 1. All right, then we have N, right? We know that N is the number of trials, and the X given, right, that's the number of successes in N trials, right? Or the number of failures in N trials, right? So let's go ahead and get started, right? There we go. And one thing I'm going to go ahead and do, because I'll be using, right, we'll need to find Q. So I'll go ahead and leave that on the top right. Right, so for part A, right, they want me to compute the probability of one success using binomial formula. Round your answers to 3 decimal places, right? So for A, right, I'm giving N equals 2, P equals 0.44. And I know how to find Q with this, right? Q is just 1 minus P. So this is going to be, Q is going to be 1 minus 0.44. Let's see what that gives us, right? Let's have our calculators handy. Right, I get here 0.56, I'm sorry. And we get X, the number of trials, to be 1. Right, so let's go ahead and plug that in, right? They want me to plug in X, 1 for X, right? So this is going to be the probability of one success is equal to N factorial, right? Which is 2 factorial over 2 minus 1 factorial times 1 factorial times P, right? My P is 0.44 raised to the X, my X is 1, times Q, right? We know what Q is. My Q is going to be 0.56 raised to the N minus X, all right? So that is going to be 2 minus 1. All right, that's how that should look. All right, let's go ahead and clean this up a little bit. 2 factorial, right, is just going to be 2 divided by, well, 2 minus 1, right? That is just right here, right? 2 minus 1, that is just 1. 1 factorial is 1. 1 factorial is just 1. So 1 times 1 equals 1, meaning, and we know anything divided by 1 is just itself, right? So in other words, I just have 2 right there, multiplied by 0.44 to the first power, which is equivalent to just itself, right? Times 0.56 to the first power, which is just itself, right? Whenever we go ahead and plug those in, I get to 3 decimal places, right? So this is my answer here, right? Right, my answer here, the probability of success would be 0.493. This is A. Let's go ahead and let's do a different one. Let's go ahead and we'll do E. Right, go ahead and do E. So E is N equals 5. My P equals 0.63. My Q is 1 minus P, which is 1 minus 0.63, which is 0.37, and my X trial is being 1. Right, let's go ahead and plug that in. So I get P, probability of 1, success for this would be, what am I looking at? 5 factorial over 5 minus X, right? My X here is 1 factorial times 1 factorial times P, right? My P is 0.63 raised to the X. My X is 1 times Q, which is 0.37 raised to the N is 1, right? N minus X, or 5 minus 1. Let's go ahead and clean this up a little bit. This gives me 5 factorial over 4 factorial times 1 factorial times 0.63 times 0.37 to the 4th power. Right. What we said is 1 factorial is just 1. So pretty much right on that first fraction, I only have 5 factorial over 4 factorial. Right. And we said on the last section, I could write this as 5 times 4 factorial over 4 factorial times 0.63. That should be a 0. Times 0.37 to the 4th. Right, we know that these 4 factorials cancel, so I should just be able to plug in 5 times 0.63 times 0.37 to the 4th power. All right, so let's go ahead and compute the probability of success, which is 5 times 0.63 times 0.37 raised to the 4th power. All right, so to 3 decimal places, I get 0.59 as my final answer. All right. So this is some of the computational examples, right, that we would stumble across for the homework and for our exam. Let's go ahead and jump to example number 2. Right, we have a word problem. A survey found that 10% of people believe that they have seen a UFO. Choose a sample of 15 people at random. Find the probability of the following, right? Round intermediate calculations and final answers to at least 3 decimal places, right? So if I'm rounding my intermediate calculations, means along the way, right, I only want 3 decimal places, right? 3 decimal places. So the first thing I want to go ahead and do, right, it's going to be to dissect this information, right? It's going to be to go ahead and dissect this information, all right? So, okay, let's see here. All right, so I'm going to go ahead and, right, let's find out what we know. We know for part A, I should have N, I should have P, I should have Q, right? So my N, right, it's going to be my sample size, right? And I read the question, that's going to be 15. My P, right, it's going to be the probability given, right? The percentage, right? I need to find the probability, so it's going to be the percentage, right? And it's not going to be 10, right? Because we've said before, we do not like using percentages as is, right? We need to go ahead and get 10 and then divide that by 100. And what's that decimal? 0.10, right? And we know Q is just 1 minus P, which is 1 minus 0.10, which is 0.90, right? And then my x. How do I find this x, right? So with these problems, it's going to be more than 1x, right? So in other words, I'm going to have to find the probability of success for x equals this, for x equals that other number, for x equals that other number, and then add them together, right? So they're asking me here, at least 2 people believe that they've seen UFOs, right? So in other words, if my sample size is 15, all right, right, at least that's going to be at least 2, right? So that's going to be means I have to find the probabilities for all of these. All right. So if you were to do this the long way, right, this would mean that we would go ahead and do the probability of success for x equals 2, the probability of success for x equals 3. That's a lot, right? But this is where negation comes in handy, all right? Because that means that you can do 1 minus the probability of success from these 2, and it'll give us the same answer, right? If you notice, computing those values right there are much nicer than computing 2, 3, 4, or all of those, right? That's going to take a lot of work. I mean, it's not going to be counted wrong if you were to do that on your exam, but it's going to take really long. You know what I mean? Really, really, really long. So, right, let's go ahead and do the negation, right? So, in other words, I would find, right, what I would do is, what I'm looking for is going to be 1 minus the probability of success for 0 plus the probability of success for 1, right? It's going to be all of those, right? Instead of finding it from between 2 and 15, right? So that's going to be my focus. So let's do that, right? Let's go ahead and do that. Go ahead and put that up there. Let's find this for x equals 0, all right? This is going to be, all right, n factorial, which is 15 over 15 minus x, which is 0 factorial times 0 factorial times, right, we said p, which is 0.10 raised to the x, which is 0, times q, which is 0.90 raised to the n minus x, which is 0. And one thing I want to go ahead and mention here is any number raised to the 0 is 1. All right. You can have really, even if you had a variable, all right, x to the 0, this would always be 1. All right. So let's remember that, right? Meaning that 0.10 to the 0, right? That's what I'm saying. It's going to be 1. So this here is the 15 factorial over 15 minus 0, that's just 15, and that's just 15 factorial, right? And another thing, right, we said on our last section was that 0 factorial equals 1, all right? So you can write the 1 in the denominator or just disappears, right? It gets engulfed with the 15 factorial, right? Times, let's go ahead and put the 1 there. 0.10 to the 0, that's just 1, times 0.90 raised to the 15, right? Step by step, right? With these, just requires, right, step by step. Well, what's cool here is that cancels out, right? The 15 factorial cancels out, meaning really all I have left is 0.90 raised to the 15. 0.90 raised to the 15. So that here is going to be 0.90 raised to the 15th. That gives me 3 decimal places, right? So this is going to be 0.206, right? 0.206. Okay, let's go ahead. All right, this was for P0. Now let's go ahead and find it for the probability of 1 success. Right, this is again 15 factorial over 15 minus 1 factorial times 1 factorial raised to the 0.10 x, right? My x equals 1 times 0.90 and n all right, which is 15 minus x, when x equals 1. Right. Let's go ahead and do this. This is for this problem, and for this problem here alone, I have n equals 15, p equals 0.10, q equals 0.90 with an x equals 1, right? Okay, let's see what this gives us here then. This here ends up giving me 15 factorial over 14 factorial times 0.10 times 0.90 raised to the 14. Similarly to before, we said this is 15 times 14 factorial over 14 factorial times 0.10, 0.90. Right, these 14 factorials cancels out, so leaving me with 15 times 0.10 times 0.90 raised to the 14. All right, and that here gives me, what do we get? Right, I get, this ends up giving me 0.343. Right, 0.343. So in other words, my answers are here and here. Right, and the reason why I wrote the formula as 1 minus bracket p of 0 plus p of 1 bracket, you need to remember that this is going to distribute to all of these, all right? So do not write it out as 1 minus p of 0 plus p of 1, right? Because that's going to give you incorrect information. The key here is make sure you put the bracket, all right? So let's go ahead and add these up. This is 0.206 plus 0.343. Right, this is 1 minus 0.206. 0.343. This ends up giving me 0.549, and this is just 0.5451. All right, so the probability of success for at least 2 people believe that they have seen a UFO is 0.451. All right. Okay, let's go ahead and let me go ahead and clear this board here so we can go ahead and attempt the second problem. Right, I have here find the probability of success. Find the probability of the following: 3 or 4 people believe that they have seen a UFO, right? So 3 or 4. So in other words, I'm going to look at these 2. Right, that's going to be pretty straightforward, right? That's going to be pretty straightforward. So case number 1. For case number 2. One or the other. Okay. Let's go ahead and plug those in, right? Let's go ahead and do it for 3. Very nice. So here, right, I'm going to slow down a little bit. So for here, of course, I want these factorials to cancel out, right? The more they cancel out, the easier the work is for us. All right, so that means that top factorial, I'm going to stretch it out up to 12 factorial. All right, because if I have that, it ends up canceling out, right? Meaning I would just have. Right, so these and these cancel out, right? Leaving me with just 15 times 14 times 13 all over, right? 3 factorial, that will give me what? 3 times 2 times 1, which is just 3 times 2, which is 6, right? Times 0.10 to the third, 0.12. Right? And this here ends up giving us, let's see what that gives us. Let's go ahead and plug all that in. I'm going to go ahead and plug in first 15 times 14 in parentheses time, right? In parentheses, 15 times 14 times 13, close my parentheses, divided by 6. It's going to give me 455. And I'm going to go ahead and multiply that 455 times 0.10 to the third power, and then multiply that times 0.90 to the 12th power. Right, and this here ends up giving me 0.129, right? This is what I get for that one. Let's go ahead and get, what are we doing? Which one are we looking at? Oh yeah, it was 3 or 4, right? So let's go ahead and find 4. This is going to be over minus 4. Right, and one, if you've noticed, right, n minus x here is the same thing as the x minus there, right? So those values should be the same, with the only exclusion would be that the one at the bottom has a factorial. All right, so then this is 15. I'm going to go ahead and plug all this in, and you may go ahead and pause the video. Right, and whenever I find it for x equals 4, right, you can go ahead and check your work. I get 0.043. Right, and it says I'm finding for 3 or for 4, right? All this states is I find the sum of these two values, right? So then this here would be 0.129 plus 0.043. Which gives me 0.172. Very nice. Right, and question C states, right, let's go ahead and clear this up. Question C, question C states exactly 3 people, right? So if it's exactly 3, right, that means you're only going to find 1, right? And so one way to remember these is if you see at most or at least, that means you're going to have a few of them, right? You're going to have a chain, right? So it can be something like the example we had, right, which is between here and here, and you have to determine, hey, which is the best shortcut you can use, right? So I think what helps is lining those numbers up, right, and lining those numbers up and see which is the easiest route, and you need to find the negation, right, the complement. 3 or 4, right, just means, hey, you add them up together. If it's exactly 1, well, that just means you're just finding exactly 1, right? So I'll go ahead and set it up for us. This is going to be, my n would be 15, my p would be 0.10, my q we know would be 0.90, and my x would be 3. All right, so your setup would be I'll let you all solve this one out for practice. Okay, let's go ahead and move on to the next example. Right, we have here example 3. Right, a student takes a 21 question multiple choice exam with 4 choices for each question, right, and guesses on each question, right? So we have more here, real world life applications, all right, real world life applications, and guesses on each question. Find the probability of guessing at least 10 out of the 21 correctly. Would you consider this event likely or unlikely to occur? Assume the variable is binomial. Round your answer to 4 decimal places. All right. So let's go ahead and see what we have here. Right. So what do we think our sample size is going to be? What's going to be my n? Right. Yes. So we answered n equals 21. That is correct. Right. What is going to be the probability? All right. Right. So whenever you're taking an exam, right, it's 1 out of how many, right? You can only choose 1. All right. You can only choose 1 answer out of how many? What's out of 4 choices, right? So that means my probability is going to be 1/4, which is 0.25, meaning my Q, right? Meaning my Q here is going to be 1 minus P, right? And when we compute that, we see this is 0. This is here 0.75. Okay, and let's go ahead and find our x values, right? All right, so we see here that they want me to find the probability of guessing at least 10 out of 21, right? 10 out of 21. And right, if you notice here, I went ahead and labeled all my numbers, and this is exactly what they're looking for. They're looking for everything greater than 10, right? Everything greater than 10. Another way to if you would have looked at this, would be 1 minus the probability of everything less than or equal to 9, right? Or another way you could have looked at this is 1 minus the probability of x less than 10, right? These two mean the same thing, all right? I mean, these two mean the same thing. Less than 10 strictly states that you cannot be 10, but you're anything lower than that, all right? So, right, this is going to require a lot of steps, right? This is going to require a lot of steps. So I will not ask you to compute something like this on the exam, right? That's crazy. That'll take us so long. That'll take us way too long, all right? I just want us to understand if we know how to decipher the question and answer exactly what they're looking for, right? So if you have a TI-83 plus or TI-84 graphing calculator, right? You can go ahead and follow these steps in the question, right? Where it shows you how to plug this into the calculator, right? If you don't have one of these steps, that's fine, all right? Like I said, I'm not going to ask you something like this on the exam, but it is required for the homework, right? So if we don't have one of those calculators, that's okay. That's all right, right? I provided the website online here. I'm going to have provided the website online. Right, and moreover, right, you can go to google.com, right, and type in binomial distribution calculator, right, binomial distribution calculator. You're gonna click on the first one, stat trick, right, and it's gonna pull up this binomial probability calculator, and you're gonna find 3 inputs here, right? You're gonna have 3 inputs. You're gonna notice that you can't type any of these, and that's fine because this is where your answers are gonna be displayed, all right? This is where answers are going to be displayed. So before I forget, let's go ahead and write out exactly what we have. We had n equals 21. We had my probability being 0.25. My Q we know is 0.75. And my focus, my lock, right, was x equals 10, right? X equals 10, because I know I can use 10 or anything greater than that, right? And what I'm going to go ahead and plug here. So for the first box, right, the probability of success on a single trial, right, that's just going to be that probability of success, P, which is 0.25. In other words, you're not going to be using Q, right? There's going to be no input for Q, since we know Q is just 1 minus P. So the calculator is going to take care of that for you. The number of trials, right, we know that was 21. That's going to be our N. And the number of success, right, it's going to be 10 as well. Right, and here, this is where all your possible outcomes may come out, right? And if you want to go ahead and use this calculator while you're solving your other problems, that's fine, because I want you to at least be able to check your answers, right? If you're doing it by hand, that's a lot of work. At least if you use this, you can be like, okay, I ended up getting the final answer. I'm correct, right? Because I want you to know how to correctly solve these, right? So, right, so for the first one is if my x equals 10. For the bottom one would be if x is strictly less than 10, if x is less than or equal to 10, if x is greater than 10, or if x is greater than or equal to 10, right? And that's exactly what we're looking for. X is greater than or equal to 20. Greater than or equal to 10, right? That's exactly what I had up here, right? X is 10 or greater than, all right? 10 or greater than. So that's what I'm looking for. So I'm going to go ahead and press calculate. And it's going to go ahead and that's my answer. That is the answer you're looking for. So the answer for this problem would be to 3 decimal places, 0.021. All right, 0.021. 0.021. Very, very nice. Let's go ahead and clear this board. Okay, let's go ahead and move on to the next problem. All right, this is going to be here, example 4. Okay, approximately 10.3 of American high school students drop out of school before graduation. Assume the variable is binomial. Choose 8 students entering high school at random. All right, choose 8 students entering high school at random. Find the probabilities around the answers to at least 4 decimal places, right? So let's go ahead and find our values, right? Let's go ahead and find our values. I know that my P is going to be 10.3%, but I don't want to use it in percent, right? I'm going to do 10.3 divided by 100, and this is going to be 10.103. My Q is just going to be 1 minus P, right? Which is going to be 1 minus 0.103. This gives me 0.897, right? My N is going to be what? 8. And the X is going to depend on the problem, right? My X is going to depend on the problem. All right, so what do we think here? It says here, no more than 3 drop out, right? No more than 3. So that means I'm going to use x equals 0, x equals 1, and x equals 2, right? Because I want no more than 3, right? So again, right, for this one, right, it is large data, right? So for this one, I'll let you go ahead and, right, again, I'm not gonna give you one this long complex in the exam, right? Well, actually, yeah, 3 would suffice, right? 3 would suffice. So let's go ahead and use our calculator, right? Let's go ahead and use our calculator. So in other words, how would you write this in terms of we were to use that calculator, right? This would be Pxs with x what? Right? X is less than or equal to 2, right? Another one would be x is less than 3, all right? So that's what I would go ahead and plug in. So let's go ahead and get our calculator ready, all right? We said that probability was 0.103, 0.103. The number of trials was it 9? 8, right? What did I say? Yeah, 8. It's going to be 8 and the number of successes, right? The one I'm locking in on. Let's do 2. We could do 3 or 2 as long as you read the correct box, right? Let's do 2, less than or equal to 2. All right, let's go ahead and calculate. And I'm going to look for less than or equal to. So I'm going to use this box right here. All right, so my answer is going to be 0.958867654, or in other words, to 4 decimal places, this is going to be 9589. All right. If you were to go ahead and put 3 here instead, right? Let's just say you would go ahead and put 3 there. All right, you just have to make sure you're reading the correct one, right? So you wouldn't be reading this one anymore, right? You'd be reading the top one, strictly less than 3, right? And if you notice, it's the same answer we got. Right, so that's how you would go about reading that. So that is the answer for this problem. Okay, let's go ahead and see the next example. Right, we were told that at least 4 graduate, right? At least 4 graduate, right? So what does that mean, right? If you were to write these all out, 1, 2, 3, 4, 5, 6, 8, at least 4, right? So I'm looking for that. So you're looking for x is greater than or equal to 4, right? X is greater than or equal to 4. So you would go ahead and plug in the same thing into the calculator, right? You would go ahead and plug in x is equal to 4, but the probability you're looking for would be x is greater than or equal to 4, all right? Or you can even use p is x is greater than 3, all right? Very, very nice. Very nice. So I'll go ahead and let you all compute this one out, right? Right, and we have here C, right? All 8 stay in school and graduate, right? Well, that means how many are dropping out then, right? How many are dropping out? Oh, wait. Let's go ahead and go to the last one, right? Since we were talking about dropping out, let's go ahead and just make sure at least 4 graduate, right? We said at least 4 graduate. And yes, that is correct. So for the last one, I'm looking at how many are going to drop out, right? So this here, my x here is going to be what do we think? All right, 0. Very nice. All right, 0. All right, so then this here is going to be, right, and you can go ahead and compute this one by hand, right? You can go ahead and compute this one by hand. Right, so this here would be right. You can go ahead and compute this one by hand, or again, you can go ahead and plug this into the online calculator, right? And it'll give us the answer we're looking for. So very, very nice. Okay, let's go ahead and jump to example number 5. Right, so now, right, you're going to be giving a sample size and a probability, and with this, you're going to be asked to find the mean, variance, and standard deviation. All right. So, and if we notice here on our top right, we see that the mean, just my mu, is going to be n times p. Right. All I'm going to be doing is multiplying those two together. Your variance, right, would be sigma squared is equal to n times p times q, right? Or if you want everything in terms of p, it'll just be 1 n times p times 1 minus p, right? Or standard deviation, we know it's just the square root of that, so you can do n times p times q, which is just n times p times 1 minus p, right? So let's go ahead and plug that in, right? Let's go ahead and find, for a, let's find my mean, right? So this is going to be, we know it's n times p, right? So this is going to be 290 times 0 0.23, right? And that gives me, very nice, this here gives me, my mean is 56.7. That's it, right? For my variance, right, this is going to be n times p times 1 minus p, which is going to be 90 times 0 0.23 times 1 minus 0 0.23, right? And that is this here is 51 points, how many, 3 decimal places, right? So this is a 51.359, right? That'll be my answer. And we know the standard deviation, right, is just the square root of your variance, which is this ends up giving me 3 decimal places. I get 7.167. Very, very nice. Let's go ahead and do D, right? D for David, all right? My mean is going to be n times p, so this is 33 times 1 over 5, which is 33 over 5, which gives me 6.6. 6.6. My variance, right, is just n times p times 1 minus p. Let me go ahead and plug that into my calculator. Right, and if you want to go ahead and use decimal places here, that's fine, right? Right, you can find 1 over 5 first, right? You can go ahead and find out what 1 over 5 is in your calculator, right? So this would be 0.20, right? Then that might be a safer bet in case, you know, the division gives us an issue when we're calculating these, right? So this, in other words, this is just 33 times 0.20. I get 5.8. And we know that my standard deviation is just the square root of that. Right, and this ends up giving me 2 point, how many decimal places was 3, right? So this is 2.298, 2.298. Very nice. Okay, and last but not least, right, example number 6. Example number 6. All right. Right, you're going to be giving a binomial distribution table, right? You're going to be given this table, and you have to determine, hey, are what you're given, is this a binomial distribution, right? You would know this by calculating each value, and each value that you calculate is given, right? That is given, right? And we'll go ahead and see what exactly am I talking about, right? So, right, one of the first things we want to go ahead and do, right, is going to be to locate my my sample size, right, my n, my x, my p, and my q, right? So let's go ahead and get started, right? I don't know my p, right, meaning then I don't know my q, right? So whenever you're doing these, your focus wants to be on that x equals 0. All right, that's your focus, and we'll see why. All right, so we know the formula is p is equal to n factorial over n minus x factorial p to the n, p to the x. Right. So for this example, my n is going to be 3, right? It's going to be 3. My p, I don't know. My q is 1 minus p, but since I don't know p, I don't know that either, right? Right. And my x value here is going to be 0. Right. And like I said before, you want to focus, right? Because you can choose this one, this one, this one, or this one to start off with, but you always want to focus on x equals 0. And it goes back to anything to the 0 power, right? Let me do another variable. Anything to the 0 power is just 1, right? And that's going to come handy right now, right? It's going to come handy right now. So let's go ahead and plug that in, right? So I have p of 0 is equal to n factorial, which is going to be 3 factorial over 3 minus 0 factorial times 0 factorial times p to the 0 times q to the n. Okay, very nice. And we already know what p at 0 is, right? We already know what that is. That is this value here, right? So in other words, you can even state you already know what that is too. P at that specific x0 is 0.001, all right? 0.001. So in other words, that entire left side is 0.001 is equal to, let me go ahead and clean this up. This is 3 factorial over 3 factorial times 1. Anything to the 0 power is just 1, right? Times q to the 3rd power. And this is what we want, right? I want to go ahead and have just one variable to solve for, right? I want to just have one variable to solve for. All right, so this meaning I'm going to have to clean this up and solve for q, right? So this is going to be 0.001, right? This is going to be 0.001. And this cancels out. This cancels out. So this means this is just q cubed, right? So in other words, q cubed is equal to 0.001. And how do I solve for this? All right, I'm going to take a little trip to algebra, right? This is, I'm going to take the cube root to both sides. And I'm going to go ahead and take the cube root to both sides, right? And if you're wondering, hey, how do I do this on how can I do this on my calculator, right? How you can do this on your calculator would be, I would do parentheses 0.001 raised to the 1/3, right? If you remember from our college algebra course, these two are the same thing. Sort of the same thing. So let's go ahead and find out what q is. Right, so we say that 0.001 to the raised to the 1/3. If your calculator already has a q function, that's okay. So this means here that my q is 0.1. Hey, I'm almost there, right? So I know what q is, right? My q is 0.1, right? And remember, the formula was q is equal to 1 minus p. So if you know what q is, 0.1, this is equal to 1 minus p. Hey, you can go ahead and solve for p now, right? So let's go ahead and subtract 1 to both sides. What happened there? Okay, so this is negative 0.90 is equal to minus p, and I'm going to divide both sides by -1, right? So I get p is equal to positive 0.90. And remember, those values, these probability values have to be bounded between 0 and 1, right? They have to be bounded between 0 and 1, and they cannot be negative. So this is, already found what p was. This is 0.90. All right, so we're halfway there. So in other words, I just went ahead and solved everything that I needed, right? I found all of that, right? So let's get started, right? I'm gonna go ahead and start on for the first one, all right? So I know that my n equals 3 my P equals 0.90, my Q equals 0.10. And the first one I'm going to do, right? So in other words, you need to prove these, all right? Now that you found your P and your Q, you're going to choose this X, and your answer must come out to that, all right? You're going to have to show your work for all of these, all right? You're going to have to show your work for all of these, all right, manually. So meaning my X is equal to 0. And let's find that out, right? Let's solve for that. So this here is going to be P at 0 is equivalent to this here giving me 3 factorial over 3 factorial times 1. We said anything to the 0 power is just 1 times 0.10 to the third. These cancel out, right? And you can say those cancel out as well, right? Because 1 over 1 is just 1. So I get here 0.10 to the third power. This gives me 0.001, right? And our job is to go ahead and see if this matches that. Hey, it does, right? It does match that. Yay. All right, so that's a complete. And what we're going to have to do now is show it for 1, for 2, and for 3. And all of these must equal. These all must be the same, right? These all must be the same. So in other words, what we're going to end up doing, what you'll end up doing here would be n equals 3, p equals 0.90, q equals 0.10, and x equals 1, all right? And you're going to go ahead and do this whole process and make sure that your p at 1 has to be the same answer, right? And right when you show, right, when you show that all of these are equal, and all of these are ends up being the right ones, then you'll say, hey, yes, this is a binomial distribution if the computed values, right, if the computed values match the values in the distribution table. All right, all of them must be the same. If they're not, if you start getting some other values in there that do not match, hey, guess what? It's not. It fails to be, right. It fails to be a binomial distribution. So you would just, right, it'll just fail. So that is all I have for today. Thank you very much for your time, and I'll see you in the next video.